Hi everyone, welcome to part two of our week two data viz class. We've now moved down on the syllabus. We've covered all this material up here. We're now in this second section here, which is lecture slides on what makes for good data journalism. I also have an extra set of slides here that I'm just going to have you read through on your own. Very important though, do play through these on your own. They don't need much narration. They're very good at kind of explaining the difference between charts and infographics and what they are, but they are very important. So that's a little bit of your homework reading to lead things off. And then there's 6 other things you have to do for next week. There's no assignments due, but there is a lot of reading, and I want you to read in advance a couple of handouts for week 3. So we can kind of hit the ground running with those. One's on the census, and this other one is digging for data. We're going to show you databases where you can go and find information, extract information from it, and then really begin that data journalism process. And we're going to talk about that process right now. This is our data journalism basics, what makes for good data journalism. We also are going to talk a little bit about chart fundamentals. As a point of introduction to, I didn't do this in my week 1 video, besides teaching full-time data journalism and digital journalism at UIC, I also work for Google through the Society of Professional Journalists Google News Lab program. And I train journalists all over the country and really the world. I've done a lot of these globally as well, and on how to use Google tools to tell great stories. So I do a lot of work with USA Today and Gannett. I've trained journalists in Egypt, the Republic of Georgia, Paris, France, all over the place. So it's a fun program, and the cool thing about this class is I bring a lot of the Google tools and resources and things that we experiment with there and use them in this class. Sometimes you guys even get to see them before I go out and use them in newsrooms. Because I'll kind of test them out with you guys, and I'll often tell you that in the videos. Hey, this is a new change to Google, or they're trying something new out. Let's play around with it and see what we can do with it. So, it's truly an experimental lab. This class is. So, I don't do a lot of slides in this class, but I think this is a good overview of really understanding what data journalism is. Journalism is going out and reporting, asking questions, finding answers, digging up information, public records, things like information about the city budget or something like that, reporting it, putting it together in a clear, concise way so anybody can understand it. Most journalists write to an 8th grade level, okay? Very simple, short, tight, concise paragraphs. Typically, no paragraph you're going to write in this class is going to be longer than 3 sentences long. They're going to be, 1 to 3 sentences long each paragraph. We link off to background information. We break up our stories with little subheads. So we really organize data or stories in a clear, concise way. We're not writing in academic prose that you might be doing for a term paper. We're going to explore a lot of the writing as we go. But right now, let's dig into data journalism basics. What is data journalism? This quote from Melissa Bell, who is a journalist technologist and really oversees data viz for Vox Media. Melissa had this quote at a panel that I attended a few years ago for the Society of Professional Journalists. What makes it data journalism isn't the form. The form is the visual, the graphic, the chart, the database, or whatever. It's the starting point in a data source we corralled, cleaned, and interpreted. So the next few weeks of this class, weeks 2, 3, and 4 really, focus on what I've got underscored here. Finding a data source, corralling it, either downloading it or scraping it. We'll show you how to scrape data out of web pages and out of PDFs. It's really cool. How to clean it up and get it in working order, and then interpret it. How to analyze it, visualize it, and take and turn it into a story. So just in this one sentence, I think she really captured the essence of what data journalism is very succinctly, which you should do as a good journalist. To quote Mark Twain, "Give me more time and I will write you a shorter letter." And what Twain meant by that is writing short, tight, concise sentences and explaining something clearly is a lot more challenging than just kind of sitting down and typing whatever happens to be on your mind at the time. This is a visual that Bell had too of the data visualization process. Finding the data is in the lower left. Filtering it, analyzing it, sorting it, filtering it, cleaning it up. The 4th step she has is visualizing and then turning that into a story that has context. And that is, develops a rising in value to the public. It gives the public better knowledge and understanding of the world around them if we were able to use data in that way. Data is not the only way to tell a story, but it is a big part of storytelling. Whether you're reading a story about sports, your city budget, an investigative piece looking into some type of impropriety, having that data to back up what people are saying and having the public records to back it up is very, very important. It gives it credibility. Well, here's another look at data journalism. This is one we all understand because as little kids, we all had Legos kind of spread out on the floor like this one at the top, where you just take them and dump them out of the box and they're laying there on the floor and mom and dad step on them in the carpet and all that kind of stuff. So that's data. Data's dirty. It's very messy. It's very unorganized. So what we see here at the top, the messy Lego set, that's typically the kind of data you'll corral. You can take and sort data. And you've been sorting data since you were probably 3 or 4 and playing with Legos. You were probably the first thing you did was sort them by color or by type of Lego. The one with 4 pegs on it or the one with 2 pegs on it. You'd organize them somehow because our minds are trained to think that way. We want to organize and structure things. Okay, so data, and this is data sorted by color. You also can take the data and arrange it. Okay, group it by color, but put it in a way that you're measuring it somehow. Presenting it visually, this is basically a bar chart. Each block would scale to something. Each block might stand for 100,000 COVID deaths, or each block stands for 100 homicides in Chicago. Whatever data it's representing, but there's scale to that, and you can present it visually. So each block means something. Each color means something. Each segment or distance in this bar chart means something. Okay, it's scale. And then providing context. Data into itself can be very dangerous if just taken and presented on the web and just put up there for people to take and do as they please. But if you provide context, tell a story with it. How does the data impact someone? I can write a story that says, well, there's a lot of potholes on North Sheridan Road where I live in Chicago. People, okay, that's interesting. But if I can take and pull the data and show that it's an issue all over the city, but really it's worse in my neighborhood, interview people, ask them about, why they think it's a problem, how are they dealing with it, hold those accountable for fixing the potholes, known as the Department of Transportation in Chicago, CDOT. And, are they fixing things and getting things done? Are our tax dollars being spent properly? So using that data to back up the story and giving it context and showing how it affects people. We saw this a lot with COVID data. We looked at the COVID data every day, line charts, bar charts, and so on and so on. But it was that human side of the story, the parent that lost a kid to COVID or a grandparent to COVID. That type of thing that really put a face on the data is the term we often use. We got to put a face on the data. Don't just give me numbers. Give me scale and a deeper understanding of it. Then we're storytellers. So this simple little silly graphic really, I think, kind of lays out data journalism in a cool way. And if you want to laugh at the Legos, go ahead. We actually use those over at Google. They have them in the lunchroom. And a lot of the developers will sit down, they'll concept things and talk through things and use the Legos to illustrate it. I've often used a Legos assignment in my in-person data classes where I give you data sets and you have to use the Legos. And obviously we can't do that with COVID or with a remote class. But I have students build bar charts much like what you see here in the fourth one from the top and actually build graphics using the Legos before they ever touch software. Data journalism allows you to zoom out and see a bigger picture. Not just the potholes in Mike's neighborhood, but potholes for the whole city. So there's a spreadsheet that the city keeps of all the pothole repairs in the city. So there you can take and analyze that data set, put the data set up there for people to search through as a database and show people the bigger picture. Okay, data journalism also allows you to sort and filter things. And we're going to do this with candy bars, kind of a silly example here. Okay, it allows you to group things together in different ways. And the sort and filter on your Google or on your Google Sheets or on your Excel allow you to do so. For instance, you can group the candy bars by those that have chocolate and those that don't. On the left have chocolate, on the right they do not. So you can group them together that way. Presents the information in a different way. You can group it by the candy that has whole peanuts in it or candy without. Now keep in mind, peanut butter cups have peanuts technically in them, but they're not whole peanuts. Snickers and Payday do. You also can group them by color. Okay, any candies that have the color orange on them and candy that doesn't. Now keep in mind, Reese's does use a orange package. Payday has a lot of orange on their package as well, but the candy itself isn't. It's always important to kind of understand the parameters I've laid out here at the top, and that is how we organize it to the T. It's not, oh, well, they have a orange package, so they belong in this group. No. It's color orange and the candy that doesn't. The candy that is colored orange, okay? It's something to be very aware of when we're grouping data and analyzing it and filtering it. Data journalism also, it provides an additional layer of credibility to your stories. I mentioned that earlier. The numbers back up, maybe what people are saying about an issue. It lets you visualize the story for your audience. It allows you to build graphics and bar charts and things like that. And we'll get into that visualization a little later in the semester. Remember that data is not a silver bullet. It doesn't cure all ills in a story. The data that comes to you is often dirty and messy, like I showed you with the scattered Lego set. Your job is to understand it, where it came from, how it got dirty, and how to clean it up. Okay, we'll do a lot of that in weeks 3 and week 4. Analyzing data can help you answer certain questions, like what questions, but it doesn't always answer the why. Oftentimes you have to go interview somebody or do some additional research to find out, well, why have homicides gone up in Chicago over the last 3 years? Answer that why question. The data helps show the what. Okay, it's going up, we know that, but why is it going up? Then we have to go out and interview people. We interview the cops, we interview criminal justice expert, a number of different people, civic leaders, things like that. You interview the mayor, the police chief, people like that. Data does not replace traditional, what we call shoe leather reporting. That's going out and interviewing people or directly observing something, writing what we see and hear with our own 2 eyes and ears. It doesn't replace that, but it does complement it. So oftentimes, you go and interview somebody once you had the data points in place and understood what the issue was with the data. Some tips on working with data. Always save the original data set. You always never want to work off the original. You want to work off of a copy. So work off a copy, give that copy a different name than what the original is. When you scrape data, oftentimes it forces you to do that, which is a nice thing, so you're not copying over the original work. Because if you do mess something up in your analysis, you can always go back to your original, and you've got that. And if you keep a good data diary as you go, you'll be able to repeat those steps very quickly. Remember the data diary in our first video, can help you write a good Twitter thread, but it also can help you backtrack your steps if you have to go back and fix anything down the road. And we'll explore that throughout the semester. Never overwrite data when cleaning it up. Always save it as a separate copy. Don't save over it. Spreadsheets. You're going to start working with these next week. And some of you have experience with them. Some of you have no experience at all with them, and that's fine. We start from square one. They can look very confusing. You see this spreadsheet here on the right. This came off the City of Chicago's data portal. This is restaurant inspections, food inspections at restaurants around the city. And you can see here in column E, it lists the restaurant name, has an inspection number, and the type. This was a food, which is a restaurant inspection. Disposition or notes from what they're doing, where they're at in their process, the city inspector, and then over here observation. A lot of these are little ticky-tack things, but some of them are very serious violations. This one group had their fire extinguisher out of place. It could be a big deal if you're working in the kitchen and it catches fire. But most of these are little small things, but there are some pretty big ones in here. They find rats and the food area and things like that, or just unsanitary working conditions, food left out, the chicken and things like that go spoil and go bad and make you sick. Foodborne illnesses are not fun. It has the name of the inspector here. Well, these are organized into what we call variables or categories, and those are typically your columns. So at the top here, you'll have a variable or column label. Your first row of your data will always be all these little labels. So disposition, inspection date, you can look at that. This is a great database. Readers love these databases because they can look up things like, their local restaurants and whether or not they should go eat there if they've had, any inspection issues. The rows of your spreadsheet are the records themselves. So the data about each one of these restaurants flows through the categories here. Okay, so your records run across, your variables or categories are vertical. Well, there are many different types of categories depending on what type of data set you're working with. If you're looking at, maybe COVID vaccination data throughout the city of Chicago, you might see, gender, race, postal code, where that vaccination took place, and so on. It could be crime data. You could look at, the victims of crimes, gender, their race, postal code, type of crime, and so on. Those are the categories. Okay. Another type of category can be or variable can be numeric. That can be age, cost, population, weight, arrests, accidents. Any numbers that appear in these columns. And this one's pretty heavy with text. If I was looking at the city budget, it'd have more numeric variables or categories, obviously, or numeric variables. Excuse me. So know your way around the spreadsheet. Always take a minute to study it. Make sure your first row has labels in it before you ever start to do any work with it. And we'll walk through these step by step throughout the semester. And I mentioned this before with Twitter threads. Always keep a data diary as you're working. Just keep a little Google Doc on the side, and for each one of your assignments, and label each step that you take. Downloaded this data set. Here's what I did to analyze it. Here's what I did to clean it up. Then I put it in this software and used this type of template in the software to visualize it. I put it in Google Flourish as a line chart. And that didn't work out too well. Wait a minute, I put it in Data Wrapper as a bar chart, and then it worked. So always have this little diary of where you go to find data and have the links to where you went and found it, and then what you do with it. Okay? So that GIF will drive you crazy. 3 keys to data journalism. Come up with a hypothesis and then prove or disprove it with the data. For me, oftentimes I see something, I walk down the street and I see, broken holes in the sidewalk. Oh man, well maybe the city's got a problem with sidewalk repairs. My hypothesis is, maybe the city's doing a poor job of fixing sidewalks. Then I prove or disprove it by going and pulling the data about that out of the city's data portal. Okay, so maybe my hypothesis in 2020, well, we had this actually in 2020. Here's a better example. In late 2020, we thought, well, have homicides gone down because of the pandemic? People aren't out as much, or have they gone up? That would really surprise us if they went up. So we pulled the city's crime data, and we pulled homicides. And started sorting and filtering it. And we saw that, compared to the 6 or 7 previous years, it had gone up. It wasn't as high as 2016, but it was higher than other recent years. So our hypothesis was kind of blown up that because of the pandemic, people weren't outside as much. Homicides must have gone down. They actually had gone up. So you never know what you're going to get when you have a theory going in or have a hunch. Reporters often refer to hunches. And if you have a hunch, go use the data and analyze it to see if it proves or disproves it. The KISS approach to data is keep it simple, sweetheart. Some of my old mean journalism professors back in the day, when I studied at Northwestern in Nebraska for my undergrad and grad, the KISS approach, keep it simple, stupid was what they called it. But I'm a little nicer about it. Keep it simple, sweetheart. What we mean by that is taking and explaining the data in the clearest, most concise way, whether that's through a visualization or through writing. And we're going to work really hard at that throughout the semesters, keeping it simple. Again, we write to an 8th grade level. And storytelling, you remember that data is about more than just numbers. Who's impacted by the data? Tell their stories. That's what people are interested in. The data is just a part of the big picture. Okay? Think about where the data might take you and build a list of questions that you want answered first before the analysis. And then we go and interview the data, ask questions of the data. We'll actually start doing that next week. Interviewing the data is much like interviewing a person, asking those basic who, what, when, where, how much. You can try the why question, but usually you have to interview somebody to answer the why question. A little more detail on KISS. Sometimes it can just be a few charts or maps that can tell a story. And anytime you create a map or a chart, apply what we call the 10-second rule. Can a person interpret your chart or map in less than 10 seconds? Convey the information to the reader visually and in written form, and do it clearly and concisely. Provide context. Okay, don't just say, homicide numbers have gone up in Chicago. Do research as to why. Link off to other articles about, the homicide and homicide rates. Interview people, and so on and so on. Providing that context is just critical. We have to help people make sense of data by keeping it simple. Here's a couple of examples. CBS Sports did one and ESPN did one of these graphics. This is right after Patrick Mahomes, a quarterback of the Kansas City Chiefs, signed a $503 million 10-year contract. Well, most of us can't relate to what $503 million is. $500 million. Okay, that's a lot of money. But how do we scale it so people can relate to it a little bit better? And both media outlets took different approaches. ESPN on the right applied it to time. Over 10 years, he gets $503 million. That's $50.3 million a year, although his signing bonus skews that a little bit, but they just did a raw average of it. Per day, so they took 365 days times 10 years, divided it into $503 million. This guy's making $137,000 a day. Per hour, they applied 24 hours to that one day. He's making about $5,800 an hour, $96 a minute, and every second he takes half a breath, he makes $1.60. When I first started working as a teenager back in the 80s, I made $3.20 an hour. He's making about half of that in a second. So it's an interesting way to break down his contract. You see these a lot in sports. This one, they applied it to CBS Sports to his playing data. So they did it, 49,000 per minute that he's actually playing. Per attempt, every time he drops back to pass, he makes $83,000. I'm a former NFL writer. I covered the Bears and the Rams, and this one just makes me laugh. Per completion, he gets $126,000 per completion, $1.2 million per touchdown. And unless he starts throwing more touchdowns, then this rate will go down. And then he makes about just under $3 million per game played so far, based on a 17-game schedule and his career averages. They averaged this out. Again, they had to explain the scale here, how they determined it for transparency. So it's kind of an interesting way to explain something. You can do this with all different kinds of data. A few years ago, we looked at cars that are abandoned around the city of Chicago. We were curious what type of car was the most common for abandonment, what color of car is the most common, what neighborhoods are those cars left in. So we began to break down this big database and scaled it in a way that people could really relate to it. Type of car, color of car, neighborhood it's left in. There's 7 common angles for data stories. Scale, how big an issue is. Okay, we have more homicides in Chicago this year than we had last year. Number 2, change or stasis. Is it going up or down over a period of years? Is there a trend there? Outliers or rankings. Where does Chicago's homicide rate? Maybe homicides per 1,000 people or 10,000 people. Where does it rank compared to other cities? So that's the outliers and ranking. Variations, you see that all the time with the COVID vaccination data. Distributions over postal codes, zip codes, or by county, by city, by neighborhood. positive COVID numbers, positive COVID tests show up as variations. Exploration, tools and simulators analysis. We'll look at databases. That's a little bit of what this is. Relationships and debunking, this would be like a Venn diagram, or when we get into Venn gauges, showing graphics and charts that, flow of money or a process or a timeline, how things are related or networked together. When we get into Venn gauge infographics, you'll be doing, probably be doing a chart much like number 6. Excuse me. Problems and solutions. Sometimes maybe there isn't a data set there, or there's missing data from that data set. Maybe that becomes your story. We've had that happen before. The city doesn't keep good records on something, and that winds up being our story. Why doesn't this data set exist, or why is it incomplete? That becomes the story. Show your work. Almost every graphic we're going to build in here is going to have, you're going to have the opportunity to share the data set that you used to build it. It'll typically appear down here in what we call the footer in the lower right here. We see source, Chicago Department of Public Health, and a link to it and your credit. Notice too, we've got a headline, a little short description up here, a legend. So we can interpret this data within about 10 seconds. We read the headline here, look at the data. I can hover over it if this was an interactive chart, and then a link to our data set right there. Okay. GitHub is very, very good at doing this. With Vox Media has a GitHub page. GitHub.com is a site where a lot of data people store their raw data, their data diaries, and things like that. You don't have to do one for this class, but if you want to, you can. It's optional. But they store a lot of their data up here, and people can go in and just open up these files and read back. They did a bunch of stuff on Uber, and you could go in and open up that folder, and you'd find their data set, their CSV file. This is a spreadsheet, and had all the launch cities and the dates for all the launch cities for Uber. You could map that, or track it in a number of different ways. So be transparent with your data, make it available to people, and show them how you came up with the process. That's why we do those Twitter threads. It's a good way to communicate to people how the sausage is made, how we do the process. Do I need a chart or a map? Is a sentence better? When I'm doing working with a data set, do I need to visualize it? What type of data do I have? What works best? A pie chart or a bar chart? A pie chart should always add up to 100%. Should always be something like a budget of some kind or some type of breakdown. What am I really working with, and how do I visualize it, or do I need to visualize it? Can I just write about the data set? Okay, here's an example of a pie chart. I'm not a big fan of pie charts. I think outside of maybe a budget, I don't have a lot of uses for them, and this is a little pie chart humor. I'm sure you're dying laughing, sitting there at 2:30 in the morning, watching this and seeing the Pac-Man pie chart. Percentage that resembles Pac-Man, percentage that does not resemble Pac-Man. It's a good way to do accounting. Break down the city budget. Where's the money going? What percentages? It's a good way to visualize that. If you're looking at the Chicago Bulls or the Bears or the Blackhawks budget, player salary budget, this is a good way to visualize it. You can break down things too, like ownership, pet ownership, things like that. It's another good way to do it. Again, I don't use pie charts an awful lot, but for certain types of data and certain types of stories, budget stories, it can come in quite handy. Bar charts and column charts are very popular. You'll do a lot of them in here. That term is used interchangeably. Column charts tend to be vertically. Bar chart can be vertical or horizontal. Bar charts typically compare percentages, data, usually over time or between entities on the x-axis, depending on whether it's horizontal or vertical. Good example is increases in campaign contributions to a candidate over a period of time, or increase in positive COVID tests. Line charts show continuous growth over or decrease over a period of time. Good examples there are unemployment rates, stock market, scoring data in sports. You see those as line charts an awful lot. They're sometimes interchangeable for data viz. Bar charts and line charts are. Not always, but sometimes they are. Here's examples of bar charts and line charts. You see the line charts over here on the left. Dot plot chart, which is very similar to the line charts. You don't have the connectivity there between the lines. There's no continuity. Column chart's vertical. Horizontal bar chart is down here on the right. And really, depending on the size of the data set, the disparity of the data set you're working with, you could probably do vertical or horizontal. You get a feel for it after a while. When we start building our charts, you'll see, oh, it works better vertically or horizontal. You just get a good feel for it. Always make sure your X and Y axes have scale on them. Typically your Y axis is going to be your numerical scale, a number of some kind. And then your categories are going to be A, B, C, D across the X axis. Again, here's an example of population. We're going to work with population data here in a few weeks. It's a very interesting time to be taking this class because it's census. 2020 census is complete, and they've started releasing the data in August of 2021. But a lot of that data release will go into early 2022. So we're still seeing some of that data. But this is the U.S. population going from 1790 all the way up to 2010 here. It cuts off. That was the last census year. Okay. Here's an interesting little chart, not my favorite chart. It's flawed. And normally if we were in class, I'd ask you guys, well, what's the flaw with this chart? Well, the sales quantity is measured over here on the left bar. So that's sales quantity, the blue line. And you can see it dropped in 2000. The expenses are over here, but there's no label for it. That should appear over here. So we have some scale for this. Because we have no idea if this is millions or billions or, what this is over here, even on the x-axis. We see a number, but we don't know, exactly how many. Is it 2,000 cases, or is this in the millions? It doesn't tell us. And by not having any scale with expenses, we can still infer something from this. If their expenses have gone up and their sales have gone down in 2008, this company's in financial trouble. Your sales dive like that, and your expenses continue on the same upswing, you've got some serious issues. You're probably going to get a new chief financial officer. They probably would have started looking at that right around 2007, and maybe mid-year 2007, 2008. Right in there. So make sure you have things labeled properly so people can understand them. But still, this one shows a pretty interesting little story. Venn diagrams we don't use an awful lot in here, but I do want to talk about them because you might run across them when we get into building infographics a little later in the semester with Venn Gauge. You have the opportunity to create them there. Venn diagrams typically are showing relationships, pictorial circles, and comparing logical sets or using closed curves within a rectangle. To show relationships, finding common elements. Where is there some commonality? So A and B are different, but where they overlap, they share something similar. Okay. Here's a good way to look at it. Where all three circles, cats, dogs, and birds, intersect, we have cats, birds, and dogs. But when only two of them overlap, we only have the two entities or the two animals. This is a little better one. When we get social, economic, and environmental, we get sustainable development. But when we just have two, we have different labels. Okay, so that shows that relationship. All right, so that's it for this lecture. What I want you to do is to go into this other deck, which is in your Google Drive, Week 2 Google Drive. It is right here. Read for background, and play through it because it's got some really good stuff in it. Definition of data journalism, what are infographics, and examples of infographics as opposed to interactive charts. Look, more Pac-Man, or this is pie humor. We got a little Yoda humor in here too to kind of break up the day. We've got some great examples of infographics and visualizations too in here that I want you to look through as well. A little bit about writing for infographics and so on, how to sketch out infographic, which is something you'll be doing when we work with Venn Gauge later in the semester. So do take some time to play through this. And do go through the homework reading that I've asked you to do. You know, assignment work is very light this week. But roll up your sleeves. Week 3, we're going to be doing a lot of hands-on work. So that's it for this week. Have a good one. And if you have any questions, do reach out.